NASA's Curiosity rover has lately been investigating the wind and radiation on Mars, providing data on some uniquely Martian weather phenomena. The probe's main objectives on Mars are to scour the planet for signs of ancient habitability. But we also have some pretty important goals of studying the modern environment, said geophysicist Ashwin Vasavada, deputy project scientist for Curiosity during a press conference today. And it's a pretty dynamic environment. Previous Mars probes, such as Spirit and Opportunity, bounced to the ground using inflatable airbag-like systems that needed to roll across a relatively flat surface. Curiosity's more accurate landing system allowed the rover to land in an area with more slopes, which has much more dynamic wind patterns. The probe measured these patterns with its rover environmental monitoring station REMS and found that, much like hilly places on Earth, Gale Crater has strong upslope winds during the day and downslope winds at night. Though Curiosity hasn't yet taken any pictures of them, its wind sensors also seem to indicate that whirlwinds are often rushing by the rover. REMS's pressure sensor has also been investigating how atmospheric pressure changes seasonally on Mars. Curiosity landed on the red planet during a time when atmospheric pressure was at its lowest point, but as springtime breaks out in the southern hemisphere, carbon dioxide is vaporizing off the planet's enormous dry ice cap and thickening the atmosphere. Earth's thick atmosphere is relatively unperturbed by such activity at our poles, but this action causes Mars' atmosphere to change by as much as 30% from season to season. Scientists are eager to watch these changes from the ground to build better models of Mars' atmosphere. If we can find out more about the weather and climate on present Mars, it gives us more confidence for predicting how Mars looked in the past, said planetary scientist Claire Newman from Ocean Research, a collaborator on the REMS instrument. Curiosity has been monitoring radiation during its stay on Mars with its Radiation Assessment Detector RAD. These are some of the first detailed radiation measurements from the Martian surface and have shown that radiation fluctuates by 3 to 5% each day on Mars. As the Martian atmosphere thickens during the night, it becomes more effective at shielding against ultraviolet radiation coming from the Sun and interplanetary space.